Awesome. You've got everything you need. Yeah. So I think most of science can be done in one of these or one of these. I think some of the greatest scientists of all time, they used whatever they could uh, collect their thoughts in. And so what I want to do with you today is um, try to do two things. Okay. The first one we're going to do is try and draw something. Okay. Once we got the basic idea of the shape, um, then once you've learned the basics of drawing, then we were going to do an experiment where we will draw what we see together. I think we can do this in under an hour. It should be pretty easy. Okay. So Caitlin, you said you do you draw as a hobby as a if not
Sometimes.
okay, sometimes counts. Okay, so I think one of the things that I find with people is we think that you need to draw perfectly in order for it to be useful, and that's kind of like saying I need to write perfectly in order for writing to be useful. And I don't think that that's true. I think we can a not good drawing is better than no drawing because a drawing then forces your attention uh, to what your brain is subconsciously noticing that you're not consciously noticing yet. And so the way I start a drawing, trying to think, let's take the Pyrex in front of you. Okay. Uh, what you want to do when we want to draw something, the first thing you're going to do on a piece of paper is uh, make a what do you call it? Like a crosshairs, essentially, like a simple grid. It doesn't have to be um, super accurate. It's just enough to give you a sense of perspective. Okay.
Okay. Okay.
All right. So you've got that, and so look at the Pyrex that's in front of you, and this is the challenge is you're going to see it from a particular perspective. Like if you're looking down at it is different than if you're looking straight away at it, right?
Yeah.
So the easiest way to do this is to try and look at it straight away and not looking at overhead because that adds a third dimension. When we draw something like this, we want to try and draw it for now as a two-dimensional perspective. So if that means uh, elevating it like on some books or something like that, that's totally fine.
That's funny.
Oh,
I
perfect. Awesome. Okay.
was reading your mind.
Yeah. Great minds think alike. So, what we want to do is we want to break this down into simple geometric shapes. I don't want to draw a complicated Pyrex beaker. I want to draw some combination of triangles, uh, circles, rectangles, squares that I see in front of me. All right. So, where do you see on the Pyrex like a circle or an oval, maybe?
Okay. I'm gonna play too.
Yeah, please do. Yeah. So I've got my cup instead, but it's the same principle. Okay. Where do you just tell me where do you see like either an oval or a circle of some kind?
Like a Yeah. circle. Yeah, I kind of it almost looks kind of square to me.
Okay.
Like a square with a squeezed bottom.
Awesome. Yeah. So if you're starting with that, yeah, you're gonna that kind of trapezoid or whatever you want to call it, or square. Yes. It's a little bit wider at the top and lower at the bottom. That's all you're gonna draw for now. Okay. Once you've
Okay.
got that first shape, then you are awesome. Now, what about the top? Let's think about the top. The top is probably going to be like some kind of really, really like thin oval almost, like from the perspective that you're looking at it. Does that make
Yeah,
sense?
like squished pancake looking.
Yeah, squish pancake. Yeah, and you want to put it somewhere in the more or less look at it in terms of the grid because you want to try and draw it relatively, not perfectly accurately sized, but think about where are things like in terms of where they are on the grid. Does that make sense?
Yeah, I have mine kind of like centered in the crosshair.
Perfect. Okay.
About what you got going on. Yep.
And are there any other shapes that you're noticing as you're looking at it? There's no wrong answer here.
Yeah, from my angle, I see kind of like I guess it looks like a really long rectangle for the handle part.
Perfect. So
It's kind of like melted almost.
that's exactly what you're going to do. You're going to add that rectangle. And there is no wrong answer. The key is don't look too much at your drawing because that's when you're negative like, oh, I hate this. This is, and then you start erasing and cutting things away. Spend most of your time looking at the object and then just glance at your drawing. Whatever you feel is a mistake, don't worry, it's not a big deal. Okay.
Okay.
So, do you have all the major shapes of your beaker? Of your
Yes,
Okay.
I
Kaylin,
do. You good? Yeah. Okay.
okay. Now that you've got the major shapes, this is when you can start to think a little bit in terms of refining for adding detail. So just real quick, like this is just my work. It's pretty simple. I've got my two ovals that I see, the sort of the top and bottom. And what I noticed, which I hadn't noticed about my cup before, is this part is thicker here than the top. I've had this cup for at least 15 years and I never really noticed that. Uh, so uh, now you can start to add little details. You don't need to don't stress about getting everything perfect. Don't like the P, but if what details are noticing on this that maybe you've never noticed before? You've looked at this thing for years.
Two bumps right on the top.
Okay. Yeah. Now are you able to so that's interesting because you see them from the bird's eye view. Can you see them from the front view? Or you like an impression of them?
Yeah, you can. They look like rumply.
Some
Yeah.
okay. That's perfect. So you what you've just done, I know this seems really simple. You've just engaged in scientific discovery. This is a thing that you've looked at for years and you've never noticed that you've noticed something new in an everyday object. And now
Yeah.
just try to subtly capture. It doesn't need to be like a big thing on your picture. Just add that into your um what do you call it? Um
Sketch.
your sketch. Don't worry if it looks three-dimensional or not. That comes later. I'll show you how to do that in a moment.
Nice. You got like the lip too.
What do you notice about the lip, Caitlin?
I noticed from this angle, like the pour spout. It looks like that when the glass was soft, they must have just yanked it downward, so the whole thing is like wrinkled underneath.
Okay, very cool. So you've generated a hypothesis as to how this shape came about. That's scientific and generating hypotheses right off the bat without even someone having to go through the whole scientific method with you. You're naturally doing this, and that's exactly the point of this activity. As you've captured some of those details, if you want to add a little hint of three-dimensional to any drawing, the simplest way to do that is to add a little bit of a hint of sort of side marks on one side. That creates basically what you're doing is you're creating a difference in color by having a little darker and a little bit lighter. Your brain will interpret that as three-dimensional. Fantastic. Yep. Yep. Okay,
Yeah.
what if I see?
Hold yours up. Oh,
Awesome. Fantastic. Good work. How do you feel about it?
It's all right.
How about
yeah.
this? Would you say that have you ever drawn this Pyrex beaker better?
I don't think so. I've ever drawn it.
Exactly. It's the best. It's the
We know,
best one
yeah.
that you've ever done. Okay. All right. So one of the reasons I think that this is important is it forces your brain to start noticing details that your brain naturally overlooks. We're really good at noticing details in 10 seconds when you're scrolling through Face Snap or any of those things, you'll see a whole lot of stuff, but it takes like 10 minutes for your brain to really notice really cool, interesting details. Like that little divot, you didn't notice it the second you looked at this. It took a couple of minutes of looking at it, and then your brain naturally noticed it. This is awesome. All right, so you've got the basics of sketching. So now I want to try apply this to a lab activity. This is going to be really simple. What we're going to do is you're going to take an egg and put it in your beaker. Okay.
Don't drop it.
Don't drop it like yeah. Okay. So do you know if you've taken chemistry, and don't worry if you don't know this, what is the eggshell made of?
I don't think I know.
I don't know.
That's okay. So what I'd like you to do is just for like in a little intro section on the piece of paper, I would just like you to write down just a couple of little notes, okay?
All right.
Eggshell equals calcium carbonate. Do you know what the symbols are? It's okay if you don't. I'll give you all of the information. I'm just curious if that's.
Let's see. I know it's Ca for
Yep,
calcium, right?
that's correct.
Ca, and then carbonate would be C. Don't know the rest of that one.
Okay, yeah. So so right off the bat, that's fine. You don't need to have all the information. You know that it's calcium and carbon. Fantastic. So calcium carbonate is CaCO3, meaning it's one calcium atom bound to one carbon atom, which is surrounded by three oxygen atoms. All right.
Ah,
This is the main material also of your bones.
Yep.
Shells, things like that, coral, all of those are basically made up predominantly of calcium carbonate. Okay. You got white vinegar? So,
I do.
Yes.
okay. So white vinegar is going to be made up of two molecules. You know one of them right off the bat, which is the main one. What do you think?
Water.
Yeah.
Yeah.
So H2O is the main 95% of it is going to be what do you call it? Water, H2O. And acetic acid is the second molecule, and that's going to be CH3COOH.
So CH3.
Yes. So the carbon is surrounded by three hydrogens,
Hydrogen.
and then there's another carbon that is double bound to one oxygen, and then another oxygen and hydrogen are coming off of it. Okay. The molecular image of this molecule is not important for this. It's just, but what we want to do is know these molecules, because we're going to do a chemical change, but with an important rule. There's an important rule in science. Have you learned anything about thermodynamics? It's fine if you haven't. There's an important rule, this law of conservation.
I might have heard
Law
it.
of conservation. That sounds familiar.
Yeah.
Sounds familiar to me.
Okay, what do you again, I'm figuring out what you know and what you don't know. What do you know about the law of conservation? Or even if you can, what can you intuit? What does conservation mean? I'm putting you on the spot, and I know that's not fair.
I'm just thinking
Okay. Well, what does it mean to conserve something?
to save it.
Yeah, that's exactly okay. So
Yeah.
what would the law of conservation suggest to you if it's this idea of saving?
Like what to save?
Yeah, so what can we say based on these molecules? What can we say about these molecules? What can we say about their destroying them?
Well, particles are made up of like something.
Yeah, can we destroy them?
Maybe.
Yeah,
I don't
so
think they ever go away, right? They
Oh.
can change from one thing to another.
yeah, that's exactly right. So the idea is that we don't, when we say we destroy something, what we really mean is we've changed the arrangement of the molecules so that they're no longer recognizable in the way that they are. So the law of conservation suggests that matter cannot be created or destroyed. Everything that's in the universe exists now, has always existed, will always exist as long as this universe is around, so on and so forth. So when we have molecules that interact, we're not destroying them. We like if you burn something, we say that we've destroyed it. What we've really done is we've converted all of the material into different kinds of material, but all of the material is still exists. If you could count every molecule, you would still get the same amount at the beginning and after the reaction.
That makes me think of your compost bin.
Yeah.
That's exactly right. So all of the food that you're breaking down, it's breaking down, and ultimately, most of that is breaking down into, do you know what is most of it breaking down into at the very end?
Dirt.
Yeah, so it's that dirt, that soil, all of those minerals stay in. A lot of the material actually evaporates as carbon dioxide and water vapor. That's why a compost bin can get warm over time. There's literally combustion happening. It is heating up as the carbon dioxide is releasing from the reaction. That's also what happens when you're burning a candle. Most of that fat is converting into carbon dioxide and water. Okay. All right. So on that happy note, what I'd like you to do is take your sketch and add the egg into it.
Ah,
And try and get it as accurately as you can. If you need to, like, use your fingers to kind of approximate it, you can think about where it is. Your Pyrex has a nice has lines to help you. You don't want it to like be the whole size of the what do you call it?
there we go. Yeah, you got that. Yeah, it kind of goes up to the one line.
This is a wonderful thing about drawing. Like when people say, I don't know how to draw, what they're really saying is they don't know how to get it like to be proportionally correct. Your brain will accept a drawing as good if it looks kind of proportionally correct. Like if you drew someone but their head was too big and like their arms were too small, that's when we're like, oh, it's cool. But if they're proportionally right, all of the details you no longer care about. All right, so we've got the egg. Now I'm going to ask you to pour your white vinegar. Sorry about the smell. If you want to open your window beforehand, that's fine. Pour until it's completely covered. Pour white vinegar on your egg. Actually, before you do that, what do you think is going to happen? Did I lose you? Hey.
Yeah, we're coming back in. There we go.
Ooh.
Yeah, we froze.
Sorry about that.
Yeah.
All right. So before we pour vinegar in there, what do you think is going to happen?
We pour vinegar in here. What do you think?
Um, the eggshell's gonna like evaporate.
Okay. Well, that's an awesome hypothesis. Can you make a note of that somewhere? Just, I think this is good. Okay. That's a great hypothesis. All right. All right. So what I'd like you to do is I'd like you to pour the white vinegar until it's completely covering the egg. And then
Okay.
I'd like you to sketch whatever it is that you see happening in the process.
Perfect.
Yep.
Okay. Put that back up on our pedestal.
Yep.
There
So
we go.
I know it's going to
Ooh.
feel weird, but stare at it. Are you seeing anything happening?
There's bubbles all around it, like little
Okay,
bubbles.
right off the bat, you're seeing bubbles. So capture that in your artwork, please. And keep just, again, you don't worry about like the perfectness of it, but do try and capture the bubbles approximately the right size? And are they all equally distributed around it? Are they in one spot more or less?
Yeah, kind of even to me.
Yeah.
Okay, great.
They look like little dots to me. Some
Okay.
of them are letting go and rising up.
Ah, okay. So you were seeing a reaction and you're seeing the reaction changing. It started by all of the bubbles were sort of like on top of the egg or surrounding the egg, and now you're seeing some of those bubbles go up. Caitlin, are the bubbles more or less the same size all over, or just
The
curious?
bubbles at the top look smaller than the ones at the bottom.
Yeah.
Interesting. Okay. So all of those little things that you're noticing, can you maybe jot a note, like small bubbles
Yeah.
at the top? The idea is your science notebook should be a sketch coupled with all of these observations that you're noticing. And it doesn't have to be full sentences. Um,
Yeah.
have you ever done this before?
No.
Cool.
Yeah, it's covered in bubbles.
Yeah.
So okay, so the react that means there's a reaction taking place, and for a reaction to be taking place, that means that chemicals are interacting and transforming and exchanging with each other. So you know that there is calcium, there's carbon, there's oxygen. Those bubbles had to have come from the calcium, the carbon, the oxygen, or from where else? What other chemicals or what other elements are in there?
From the vinegar?
Okay, from the CH or the O. What else? There's a third ingredient of the which is the main one because it's only
The
like
hydrogen?
the water has
Yeah.
H2O. So the question is, what are these bubbles? The bubbles have to come from some combination of those elements.
Hmm.
So what are bubbles in liquid?
Oxygen.
Okay, so one possibility is that oxygen gas is coming off of this. Oxygen gas is O2. So one possibility is that O2 is coming off. So what I'd like you to do is I would like you to draw with arrows how you think the chemicals are moving and be specific. So if you think right now the bubbles are O2, like literally draw O2. Do you see what
Oh.
Okay.
okay? So O2 is probably one of the most common gases that you encounter. What other gases do you encounter?
Carbon dioxide.
Aha. Okay. Could this be carbon dioxide?
Maybe.
So you're right now, all you're doing is you're putting ideas down on a paper. I am not trying to tell you here's the right answer. Is it possible that this is carbon dioxide coming off? Is it possible that it's oxygen? Okay.
Possible, yeah.
Okay. So you need to, because you already had hypothesized that the eggshell is evaporating. So what you need to do is think about, you need to account for the carbon, the oxygen, and the calcium. So some of the oxygen of the calcium carbonate might be coming off as oxygen gas. Some of it might be coming off as carbon dioxide. You have accounted for two of the three elements um, of the shell.
Hmm.
Where's the calcium going? Just keep looking. Do you see anything happening? Is there
To the top?
what evidence do you have to support that?
Some like small, really tiny bubbles are grouping to like the top and like kind of like a corner.
Okay, so is there anything that physically different about that?
Um,
It looks kind of like foam to me.
yeah, almost like foam.
Okay, so if you're seeing, that's great. If you're seeing foam, try and capture that in your sketch. And what do you think that foam is?
Yeah, I don't know. Would calcium be light enough to float on top of water?
Maybe.
Does it? So there's lots of different. I'm not going to tell you what the right answer is. I want you to generate the hypotheses and just put down what you think is happening and then give evidence to support your idea. If it could be that that's pure calcium that's floating to the top as foam. If that's what you think, put that down. What other possibilities are there? Remember, calcium carbonate is CaCO3. It doesn't have to be pure calcium. It could be just like the carbon dioxide. It doesn't have to be a complete separation. Could it separate with something else?
Carbon monoxide?
Ooh, possibly.
I hope not.
Well,
That's bad.
it's possible. You collect all of the possibilities and just sort of write them down. So we've got maybe CO, CO2, O2. Could there be any other possibilities? You said pure calcium. Now, would that be a gas, you think?
Not a gas.
Why? You're right, but I'm just
Are you thinking because calcium is not a gas?
Yeah.
yeah. Well, you can think about how you know about where do you like when you think about calcium, where do you encounter it?
Like in your bones?
Okay, yeah. So that kind of solid material does not easily become a gas. So if it's coming off the shell, what is it likely to uh, what state is it likely to maintain?
Yeah, I would think it would be a solid. If it was
Yeah,
calcium,
it was
would stay
calcium.
a solid.
Yeah.
Okay, so maybe one place it could go is it could go all the way to the top of the surface of this vinegar solution. That's a possibility. Where else could it go?
We can,
Just be floating in the vinegar.
yeah.
Ah, maybe it could just be floating in the vinegar. And if that's the case, what would be where would you see it?
Not very well.
Absolutely right. So again, what I'd like you to do is try and with arrows and with however you want to express it, but show the movement of all of the potential um, uh, molecules.
Okay. We might have calcium out here swimming around.
Has it continued to transform in any way since you first started?
I feel like the egg has shifted a little.
I feel like it got bigger,
It does look bigger.
like fatter.
Great, write that down. Whatever you're noticing, the goal is to articulate and to capture what you've noticed.
Yeah, because it looks like it's kind of rotated a little.
Interesting. It's rotated. Something so it started kind of like obviously at the bottom and it's floated a little bit. Okay.
Yeah, because I know we can test an egg. You can test it in water to see if it's a fresh egg or a spoiled egg. And if you put an egg in water and it sinks, then it's a fresh egg. If it floats, then you've got a stinker and you should get rid of it.
Yeah, that's
Do
true.
not eat it.
I love that you're and this is I think really important that within science you want to connect, it's not just a bunch of facts that you learn in a textbook, it's what you've learned in real life that you can how you can connect it to stuff that you know from outside of science. That's how you retain this stuff.
Yeah, so I don't know what that means for floating in vinegar, though. It's not really floating, I don't think.
Yeah.
No, we're not floating.
The vinegar looks like it got shallower, like less.
Yeah, it does, because the top of the egg, because you poured it When, yeah, you poured extra in there and now the top of the egg is just breaking the surface of the vinegar.
Yeah.
Nice. But it didn't start that way. You're saying that it's moved and
Now it looks like it looks like the egg is bigger and
Like
taking up
taller.
more space, and
Interesting.
now it's level with the top.
Very cool.
Yeah.
It also changed shapes. Like in the middle looks way more wide compared to the bottom.
Yeah, it does. It looks more round instead of egg shaped.
Find a way to capture that. So everything that you're saying, this is what I do with these is my job becomes less teaching and it becomes more a reminder to students to write down what they're noticing because we don't like to write. We like to just say things, but then those thoughts disappear.
Yep.
So whatever you notice, write down, and maybe you'll explore that more in depth. Maybe you won't. You just, as long as you've captured a dozen observations, then you can figure out afterwards, what do you want to explore in more depth later? So I'm just going to keep letting you observe until you feel like you've exhausted your sets of observations. Um, Things that I look for are transformations, changes in shapes, um, anything that your senses can observe. I mean, even things like smell are part of your collective observations.
Yeah. And it's interesting because I don't think the liquid level hasn't really changed, because when you poured it in there, it was just above that 1 cup line right here,
Yeah.
and it's still there, but the egg is now peeking out of the top.
Now, this is also, if you want, you are able to manipulate. I mean, whether you want to touch the egg or not is one thing, but if you have I don't know, another pencil or something, if you wanted
With
to
a spoon.
manipulate what you're looking at, you have means to do that. They're like, I am not trying to limit how you go about observing this.
Okay. And I also brought another egg.
Oh, nice. That's awesome. I love that. You've got
What do you
something
think?
like as a control kind of.
You got me very well.
All right, you want to roll the egg around?
It got much heavier.
It's heavier?
It is, yeah.
Ah.
Interesting.
Is the shell smooth, or is there like a texture on it? You can touch it. It's not going to hurt you. How's it feel?
It like its skin is like peeling off.
Oh.
Please
Wow.
write that down somewhere. Yeah.
Yeah. Chunky. Looks like it's peeling off sunburn going on.
Yeah.
Ooh, I love that. I love descriptors like that because pretty much everyone can understand that. I mean, unless you've never been out in the sun or something, like I'm willing to bet everyone in North Carolina knows what that feels like.
Yep. Yeah, that's funny. So was it floating before? Because you put it back in there and now it's not touching the top of the ceiling or the top of the water. Interesting.
So what I'd
So
love
was
you to do is add a little section to your notes that just says questions and just write down every question that you generate as you do this.
So was it floating? And it definitely looks bigger.
Yeah, that's actually, I think that's actually a really great way to compare because eggs, almost by definition, you buy them from the grocery store. They have to be standardized enough to fit in uh, an egg carton.
Right.
So you can fairly confidently say that. Ooh, I'm seeing like the back side of or the opposite side that you're touching. It looks slimier. If you can look at the other.
Yeah.
So is
And
it
there's
equally slimy everywhere?
yeah, and there's like a residue that comes off.
Nice. Yeah.
Mm.
What do you
Okay.
think that residue is mainly? What element is that residue mainly?
All right. So it's got to be part of the calcium or and the carbonate because that's what the eggshell is made out of. So it's got to be one of those things.
Hmm.
What do you think? Oh, that's weird.
I think it's
What,
calcium.
okay,
The
that's
calcium?
awesome. You've got a hypothesis. You've got this idea of like the calcium residue. What did you say, Emily? That's weird. What did you notice is
The like I was thinking about since we used a brown egg and we're getting all these brown like the residue, that smeary looking slimy stuff. If we had used white egg, would we have noticed that or would it have blended in or looked different?
great question, right? So, this is the thing about this is when I do these, I am not looking at this as though I'm the expert. I'm not the expert on eggs or calcium carbonate. We are all observing this collectively together. Uh, when I've done this with my class, I've done this with white eggs. So this is my first time doing this with a brown egg. So y- I've been doing these things for years, and right now. Caitlin, you are teaching me something by having chosen a brown egg and the things that you're showing me. And honestly, you guys also the first group to go and get like a control comparison.
Yeah, and it had like all that the brown egg, the outside of it is all like coming off like tissue paper almost, like wet tissue paper.
Amazing, yeah.
Yeah. Huh. It's kind of given there's a lighter tan underneath it.
Very nice. And if you can capture that in your sketch, this is a nice opportunity to, as you're, there's how you sketch. And the reason I harp on this is because it will make you notice more whether you want to do a second sketch of the egg or just capture it in the as it is. You do want to be able to, because science is not just about what you're noticing, it's also about what you're able to share with other people. So noticing and capturing this idea of like, oh wow, it's like layers to this, and it's darker brown and then lighter brown.
Mm-hmm.
What are you noticing, Caitlin?
What do
I
you think?
think the stuff floating around is calcium
Okay. What's please support that idea.
because it seems like that was kind of like the hard layer on the egg, and it just kind of seems like calcium like hardens if it can be a bone.
Like the hardest part would be on the outside?
Yeah.
I
Okay.
think that makes total sense. That is really insightful. You had what I call the aha moment.
Hmm.
Um, and I could recognize the aha moment because you were eager to share it with your mom. Like when we
Yeah.
have aha moments, we inevitably want to share them. Uh,
Yeah.
so if you were my student and you had captured that and you wrote down all of that information, that to me, you have fulfilled the most important goal that I have for a science observation is to have that aha moment. And you came
Wow.
up with a hypothesis that you supported with the evidence that you collectively have.
Hmm.
Yeah, and now the dark layer from the outside, the darkest layer is pretty much all peeled off.
Yeah.
Nice. Curious, does
So
it feel different though, that lighter layer when you touch it versus
yeah, the outer layer feels really slimy and that it feels thinner. The eggshell feels a lot thinner.
Yeah.
very nice.
It feels fragile,
Okay.
not like this one.
Is it still bubbling?
Not as much.
Not as much, but a little bit.
Yeah.
Okay. So the bubbling is important. That's telling you that what we call a displacement reaction is happening. So
Yeah.
as long as those bubbles are happening, that means something is exchanging. So something is interacting with the calcium carbonate and the acetic acid. They're exchanging atoms. Essentially, what is happening is
That's right.
you were correct that the calcium is dissociating, it's breaking off from from the carbonate, and that calcium is dissolving into solution. And so what will eventually happen is it will be indistinguishable from the water. It will basically, just like salt water, uh, you've got sodium and chlorine. It will that you can't see, but then if you were to boil your salt water, you would have the residual salt. That's what you would get. So that calcium is going to dissolve into the liquid solution. And as you correctly said, the bubbles are gas, and it's going to be some mix of oxygen and carbon dioxide. Now, notice I didn't teach you anything except for the first part of what is eggshell made up of, and what is acetic acid made up of. You figured everything out on your own through your own observations. All I gave you was a couple of pieces of chemical information to latch onto, so that you could, just for you to have a more specific uh, description. Because if I hadn't given you the scientific words, you would have said, "Oh, it dissolved," or "it disappeared." You would have kept it vague. But once I gave you the specific language, you could be a lot more specific in how you describe the process.
Yeah, the bubbles on the egg now they look big again. Like it's like
Interesting. So the
another,
reaction.
yeah.
So what do you think is happening there? If the
The
bubbles are still going on, what's going on with this reaction?
more of the shells going away.
Maybe.
Yeah.
Let's let's think through this. Let's make a hypothesis, because I'm not going to sit here with you for 4 hours or however long. How long do you think it will take for this reaction to fully complete, where there's no more bubbles at all?
30 minutes?
30 minutes. I would say my guess would be longer, but
Okay.
Well, okay, well, just curious. What makes you what makes you think 30 minutes?
Just at the rate how it's going.
well, yeah, I guess that's a good point.
Right,
We've
that
had
makes
it
sense. Yeah,
in there.
you've seen basically that first layer dissolve, and we've been doing this for a little more than half an hour, believe it or not. Um,
Hmm.
so okay, so and what do you think whenever this reaction is completed, what how will the egg be transformed? What will happen if the calcium is completely dissolved? What will be there?
I think just the thin shell that feels
Like the membrane on the inside. So will it
maybe.
feel more like a turtle egg? You know how they're kind of like
Yeah.
leathery and soft, like a like a
Okay.
squishy.
So what you have there is a future lab. The idea is like, okay, here's what we can look at in the future. So whenever you want to look at this reaction, you want to see how it you've made a prediction now that when this reaction is completed, this is what it will look like. And that what I love about your prediction is it's testable, because all you have to do is leave that in there
Yeah.
for however long you want to leave it in there, and see how long the reaction continues. How would you document if you were to continue observing this?
I would probably set up like a camera to reveal everything.
Oh, that would be cool. You could do like a time lapse.
Yeah.
That is absolutely great. What would be a lower budget way of doing that?
Yeah, that.
Yeah.
What did you do? What did you do? Let's, you know what you should do? Put the date and time. You had started this at 6:15.
Yeah,
Put on your drawing, just put 6:10, 6:15 p.m.
that's right. Because for science, you're supposed to write down specifics, like how long something took, right?
Yeah. So what could you do half an hour or an hour from now?
Look back to see how much it's changed compared to the 30 minutes before.
Yeah, just draw it again, because here's the thing. Like the reason the drawing is valuable is it forces you to notice the details. If I had asked you to look at this for 10 seconds, you wouldn't have noticed the dozen things that you would listed. If we were trying to like get this quick, you wouldn't have noticed, and you wouldn't have had that aha moment if we had just spent a couple of seconds looking at it. So what I would like to ask of you, it's not my place to give you homework, but I'd like you to tr look at this again in an hour and in a day and draw both and just write down what you've noticed. Okay. What that does is essentially it gives you a continued scientific investigation to do, a scientific lab. And so if you notice, it's only taken however much an egg costs in North Carolina and however much white vinegar costs. Uh,
Yeah.
and that's it. So, Caitlin, what I'd like you to do is I'd like you to write down
Okay.
a reflection on this. So, for a reflection, what I mean is not, oh, this was fun. What surprised you? What did you think would happen that did happen, or what caught you off guard? What did you not expect to happen in this
I
reaction?
didn't expect it to peel off like with like gooey chunks.
Okay,
Yeah.
great.
I would agree with that. I wasn't expecting gooey chunks either.
Fantastic. So your reflection, what I'd like you to do is, and this can be bullet points, this can be however you want to write it. Write down what surprised you, and then how would you follow up to find out if you were to redo this, what would you do? What might you do differently?
I might write down what time I put it in.
Okay, how come?
Because I didn't, and
Okay. Why? So I think your instinct to want to time it is interesting. Why might that have created a slightly different outcome?
I guess it doesn't really affect the egg much.
Yeah,
Not necessarily, but how does it affect what you observe?
Just knowing what time you put it in
and then knowing how long it took between
and
like
what
when you
happened
started it
and
and
how
when
long it takes to like until it started peeling off. And
Yeah.
Yeah, so that would be, so what you've just come up with in your reflection is a possible future experiment. I'm not saying that you're going to do this, but it is a possible future experiment. Like, okay, let's see what is the rate of this reaction? How much will dissolve in a minute? How much will dissolve in 10 minutes? That's a future experiment could be looking at the rate at which this reaction changes. What else? What other variables could
I
you?
would we used white vinegar. What happens if we used, say, a dark vinegar? Would it be faster? Would it have more reaction?
yeah.
You don't know one way or the other, but it's a possible experiment that you could examine the idea. And this is
Yeah.
what I didn't hear. What did you say?
Use a white egg instead?
Sure. Yeah. So all of these are this reflection. What you've done is you've created a series of potential experiments to develop an expertise on a particular topic. You you could, with 6 eggs and a couple of days of patience, uh, develop an incredible understanding of this displacement reaction. This is something that we talk about in chemistry. Within just a couple of iterations of this experiment. Um, and there's literally 1,000 different ways you could transform this. How might temperature affect this?
Oh, yeah. If you heated up the vinegar, would it do anything different?
It might bubble
It'd
more.
probably smell worse.
Yeah.
Yeah, that's interesting. Yeah, so that is adding an interesting variable. So all of those are just little. What I'd like you to do is just write down even a word or two just of these reflection ideas, like just even a word like how might temperature affect it.
Yeah, and then you could do temperature of the egg or temperature of the vinegar. Like if
Hmm.
the egg was room temperature, because these came out of the fridge. So, but if they were room temperature eggs, would that change anything?
I don't know.
Of course you know that, but that's the creative joy of the experiment. What else could you do? How else could you transform the egg before you put it into vinegar?
Put it in the freezer first.
Ooh,
Oh,
frozen egg.
frozen egg. Okay, great. Now let's do the exact opposite. Let's
What
look
if it was a broken egg
I don't
hmm,
know.
or
or a
a boiled
boiled?
egg. What about a hard-boiled egg? Do you think a hard-boiled egg might behave differently?
Yeah. Would the shell still, I mean,
I
it
think
would
the
still
shell
be the
still
shell.
would, but the
Yeah.
insides would probably be different.
So if the insides are different, what do you can you hypothesize? Would that change the reaction on the outside?
I think the outside would still probably peel off, considering
It's,
the
yeah, because
shell wouldn't change much.
boiling it wouldn't change what the shell is made out of, right?
Yeah.
Okay. You right there comparing a hard-boiled egg in vinegar to a non-boiled egg in vinegar, you've just come up with an experiment that is testable. And you've literally said you could through timing or whatever, you could see whether or not your hypothesis, you generated an experiment with just with your imagination and creativity.
Hmm.
Okay. You have undergone a process of scientific investigation that people used to do before science became like a job and people said you had to go get a degree to do all this. This is what people kind of did. We just tried to tinker in our kitchens, figuring things out and writing down what we noticed. The drawing just helps you pay close attention to the details. And what's really important is it helps you share what you've noticed because if you were to share if you just shared this without a picture would your dad want to read it?
Probably not.
But what does the picture allow you to do?
To show it,
Yeah.
Yeah,
to show them what actually happened.
it's exactly right. The picture you've heard the phrase a picture's worth 1,000 words.
Yep.
The idea is that
Yeah.
by looking at your image and looking at the writing around it, the image tells me it's like a preview of what you've written out. So I don't have to like put in a lot of effort to figure out what you're trying to tell me.
Mhm.
Right? Right. That is it. That is my shtick on being like a scientist. You have spent the last hour seeing like a scientist. What do you think?
I think that was interesting. Yeah.
Yeah, that's cool.
Good. I'm curious.
Huh.
What surprised you about the activity?
I didn't think eggs would come off with like this weird substance.
Yeah.
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 So, yeah, you can actually like fish it out. There's like chunks of,
Yeah.
Yep, and that all of this is opportunities for your curiosity. I don't know if you have a microscope. You can look at this under a microscope, things like that. You can dry it out and see how it looks. There's all of these different opportunities for you to continue the investigation. I'm not telling you that you should, although I do think you should look at this and draw it again.
it was
Actually, what I'd really love for you to do, if you wouldn't mind, would you
yeah,
mind drawing it again either in a couple of hours or in a day and just telling me and sending me an image of how it's transformed in that time?
sure. Yeah, we'll draw it tomorrow and see how it
Okay.
looks.
Awesome. Okay. Well,
Yeah.
I think that I've taken up an hour of your evening, and I am super grateful. Um, so that is it on my end, Caitlin. I don't
All
want
right.
to continue to.
Missed.
Okay.
All right. Thanks for participating. You're a good sport, Kate.
Thank you. I really appreciate it.
She's a good kid.
Yeah, you should keep her.
Yeah, I'll keep her. Yeah. It's funny, just about 2 hours before this meeting, we got a new puppy delivered. Yeah. He's like this big. He's sleeping in his crate right now. He's so cute.
Oh, that is
Yeah.
adorable. If
Yeah.
that's also the kind of activity of like sketching his growth and development over the next couple of weeks, that would be
Yeah.
another perfect kind of thing for a science journal.
Yeah, for sure. On an unrelated note, have you ever heard of George Washington Carver?
Yeah.
Okay, because your work, he keeps popping into my head every time I'm like you're talking about sketching for science, because he was like he used to do that, make his own paints, and he used to go out and plant and draw peanuts and all kinds of stuff.
Yeah.
That reminds me of his.
Yeah, and he was, I mean, an incredibly prolific scientist. Yeah,
Yeah,
yeah. I'm a big fan of the work that he did. Um, I, I think, and that one of the many things that I love about this is it allows you to tie history into the science, because it makes what they've done. It's not like, oh, you have to be some kind of hyper genius. You just have to be kind of curious and be willing to
right.
spend time paying close attention.
Yeah, and that's the cool thing about him that I've always thought was interesting, is this was a guy who really came from a very humble background, and he just basically was curious, like you said, and just started doing stuff and looking at stuff and experimenting, and wound up being one of the most, influential farmers and scientists in the South, which was pretty neat.
Yeah, you know what? I think I'm going to spend some more time uh, researching him, because yes, I mean, his work is stuff that I've been familiar with, but I
Right.
definitely like to do a deep dive on his work. Um, I don't want to keep you too much longer, but I'm just curious, uh, your thoughts just generally about this activity as a parent and watching your kid do it.
Oh, that was really cool. That was a lot of fun. It was nice, especially being that, like, with homeschooling, it's fun to have an outside
Mhm.
influence, so it's not
Yeah,
just me, because it's more, I don't know, I guess that's why teachers are cool, because it gives you that extra, like, oh, don't take it just from me, I'm your mom.
yeah, yeah.
Yeah.
What do you know?
What do you know? Nothing. Yeah. Yeah, it's funny, as a mom of teenage daughters,
Oof.
oh yeah, it's crazy, because like they look at me like I'm the dumbest human with no life experience, and I'm like,
Guys.
guys, I might know a thing or two. Nope, no.
Amazing.
Ugh.
I gotta say, it's also really it was beautiful to watch the two of you collaborate on your investigation. That was a really lovely thing, just to see a mom and daughter like sharing the
Yeah,
process of discovery together.
yeah, that's fun. I
Yeah.
like. We'll have to see. We'll keep this on the counter and see what it looks like
Yeah,
tomorrow.
exactly. Very cool. Yeah. Do you mind taking a photo and with your sketch and let me see what
Yeah,
you think?
yeah, we'll do it.
Awesome. So I'll bother you later and just get your sort of a feedback if you don't mind.
Sure.
Thank you very much
Yes.
for all this time. I really appreciate it.
Yeah, no problem. It was good to see you.
Good to see you too.
All right.
Take
Take
care.
care.